Okay, so we are on page 13. Okay, really quick review. Let's have you guys try those two. So just logs with other bases, trying to solve them. So just like the warm-up and just like the homework we did a few days ago. So go ahead and try to solve them, and we'll do other ones soon. So most people have the first two done. I think everybody has the first two done, 3 and 5. So you're working on the next 4. So number 1 is e cubed plus 1 over 4. Number 2 is 79 over 9. All right, number 3 and number 4, common mistake is to distribute that base. So a lot of you did this. That is incorrect. So you have to combine it into one log first before you solve. So you got to do that first, okay? And this one is going to give you 2 answers, 16 and negative 4. Negative 4 won't work, so it's just 16. So make sure you check your answer. Number 4 is the same thing. If you just distributed a base 4, that will not work. You have to combine it into one log. So that is x equals negative 1/5. All right, last thing today, and we are done, and we should have time to do homework. Okay, so we learned one graph this at the beginning of the chapter. So this time we're going to learn the other graph, which is log graph. All the log functions follow this transformation rule just like before. But this time it's going to be a little bit tricky because, you don't know how this graph looks like. Okay, so let's graph log x. To graph log x, we're going to, again, use some negative numbers, 0, and some positive numbers. So let's start at negative 1, 0, 1, 2, and let's just put a few numbers since we don't have a lot. Okay, the x values goes into log x. So log negative 1. What is log negative 1? Nothing, right? We said there is no negative numbers in log. Okay, what about 0? Log 0. Nothing, yes. You can't have 0 or negative numbers. So nothing happens over there. Let's try log 1.
0.
Yes, 0. So that's one of the properties you have to remember. Any log of 1 is always 0. All right, log 2, this is where you use your calculator. 0.3, thank you. Okay, and then log 3.
0.477.
Okay, so let's do 0.5. Okay, so negative 1 and 0, nothing goes on. At 1, it's 0. At 2, it's 0.3. 3 is 0.5. Okay, that does not really give us a good picture of how this graph looks like. Let's try a number between 0 and 1.
0.5.
Okay, 0.5. So log 0.5.
Negative.
Negative what?
0.3.
Okay, negative 0.3. So it's going to be somewhere here. Okay, and then we can try more numbers, but this is a graph that's going to look like this. It's going to go up very slightly, but it is going to go up. And then on the left, we know that there is no number that's smaller than 0. So this graph is actually going to look like this. It's going to go straight down. And this one, just like the the exponential functions, has a asymptote, but the asymptote goes this way. So the exponential function, we have a horizontal asymptote. There is like a lowest value. It's never going to go below. For the log functions, there's a vertical asymptote. Vertical goes up and down, and it's not going to go to the left of it. Okay? All right, so this is our graph. All right, let's review. Let's see if you can kind of think about it. Let's write it out. What is the domain of this function? Yes, greater than 0. So all the possible x values. The graph is going to not touch 0, but it's going to exist on the right-hand side of 0, so it's going to be greater than 0. Not equal to, because there is nothing going on at 0. What do you think the range is?
All real numbers.
Good, all real numbers. All right. Where do you think the y-intercept is? There is none. Yeah, there's none. It doesn't cross the y-axis. What about the x-intercept? 1, 0. Yes, correct. 1, 0. All right, let's try natural log. All right, natural log, again, negative 1, 0, 1, 2, 3. Put in negative 1, what do you get? Nothing. It follows the same rule as normal logs, right? So what about natural log 0? Nothing. Okay, natural log 1. Oop, there is something. 0. Yeah, any log of 1 is always 0. All right, natural log 2, use your calculator. 0.7, and then natural log 3. All right, let's do 1.1. Okay, let's put in the numbers. 1, 0, 0.7, 1.1. Okay, let's try a smaller number then, because not enough points. Okay, so 0.5, huh? 0.5? Negative 0.7. All right, so that's going to be maybe right here. Okay, so this graph is the same idea as the other graph, so it's going to have a vertical asymptote again. On the right-hand side, it goes up slowly, and then on the left, it just goes straight down. So that means there is also another vertical asymptote. Okay, let's look at domain and range again. What is the domain? Okay, x greater than 0, and then the range?
All real numbers.
Yes, all real numbers.
Can there be 2 asymptotes in the graph?
There could be, but not for just regular logs. Okay, next, vertical asymptote. So this is the word that you need to learn. Vertical means up and down. Asymptote means that line that you cannot cross. So the definition is the invisible vertical line that the graph cannot cross. Invisible vertical line that the graph cannot cross. This one, it really cannot cross. There is no way to cross a vertical asymptote. All right, let us practice and we are done for the day. We need to find the parent function and transformation. So if we look at number 1, what is the parent function? Log x. Yes. You have to be able to identify the parent function first before you can find the transformation. All right, there are 3 transformations. What are they? Stretch 2, right 2, up 1. Okay, time to graph. Before we graph, let's try to predict. Okay, so think about your normal log. Log base 10, sorry. Log base 10 looks like this. So we're going to stretch 2, so make it a little longer. Right 2, up 1. Okay, where do you think the vertical asymptote is going to be? 2. Someone said 2? Okay, yes, at 2. Because we moved the whole graph to the right 2, which means we moved that vertical asymptote also right 2. So you want to have an idea of how this looks like before you start graphing. That way you won't be like, I don't know if it's right. But we are ready to graph. So we want to be able to choose points that's, that makes sense. So since we moved right 2, you should start at 2. Just like when you are doing the exponential function, you want to be smart about the numbers you choose. I'm just going to go higher. I don't need to go lower than 2 because I know that there's nothing that's going to happen. 2 is my asymptote. Okay, so 2 log 2 minus 2 plus 1. That's going to give me log 0, so nothing's going to happen there. That's my asymptote. 2 minus 2 is going to be 0. Log 0 is nothing. So let's try 3. 2 log 3 minus 2 plus 1. This one you should be able to do it in your head. Huh? Not 3? 1. Because 3 minus 2 is 1. Log 1 is 0. Yeah. And then 0 times 2 is still 0. So plus 1, 1. Okay. All right. Next one. 2 log 4 minus 2 plus 1. This one you had to use the calculator. 1.6? Okay. Thank you. 1.6. Let's try one more number so we don't have a graph that only has 2 points.
1.5.
Hmm? Wait, what?
Rounds to 2.
Oh, 2. Okay, got it.
It's 1.9.
Okay. All right, so we know there is an asymptote, vertical asymptote at 2. At 3 is 1. At 4 is 1.6. 5 is 2. All right, so the graph's going to look like this. Okay, what is the domain? X is greater than 2. What about the range? All real numbers. Let me ask you a tricky question. What is the x-intercept? X-intercept is when what happens? Y equals 0. So that means we need to solve. So let's try solving it. 0 equals 2 log x minus 2 plus 1. How do I solve this? Minus 1. Divide by 2. Oops. Now what? Yes, raised by 10. So kind of goes back to our lesson, right? So 10 to the negative 2. 10 to the negative 1/2. 1 over square root 10. So let's do this on the side. 10 to the negative 1/2. Negative means put it in the denominator, or it's in the wrong place. And then 1/2 as an exponent means square root. So it's 1 over square root 10. Okay, 1 over square root 10 is equal to x minus 2. The last thing you want to do is just add 2. So x is 2 plus 1 over root 10, and then you would just use the calculator to figure out what that number is. Doing okay? Huh?
Comma 0.
Oh, yeah, right, comma 0. Sorry, if you were to find an actual point. Are you guys doing okay so far? Maybe? Okay. Okay, so let's have you guys try one on your own. You're going to do the natural log on your own. So the parent function is natural log. So let's finish this one. Okay, this one is left 1, down 4, reflect x-axis. Okay, so on your homework, I don't expect a perfect graph, just a sketch is good. So on this one, left 1, that means your asymptote is going to move left 1, down 4, so then we have a point at 0, negative 4. And this is reflected over x-axis, so it kind of looks like this. Okay, the domain is going to be x greater than negative 1, and the range is all real numbers. Okay, so what you want to do with your homework, so for example, number 1 on the homework. Number 1 on the homework is log base 6, x minus 1 minus 5. Since it's base 6, if you really, really do want to find the exact number, you would have to change base to find that, and that's going to take too long. So here's what you would do. Okay, so what you do. Okay, so this graph is going to be right 1. Okay, so that means your asymptote moved right 1. Okay, down 5. All right, so let's think about your original graph. Your original graph looks like this. It has a specific point at 1, 0. So what you can do is just think that 1, 0 is moving. That 1, 0 moved right 1, down 5. So it's going to be right 1, down 5. And then just a sketch is good. So you take the point that you know for sure, which is 1, 0, and then you move it around. And then you basically graph everything else relative to that point. Silence means maybe you don't get it. Okay, so go ahead and try a few on the homework. If you are still stuck, let me know.